What if the sun went dark just for 10 seconds? Imagine you are standing outside on a bright afternoon. The sky is clear. The air is warm. Suddenly, without warning, everything goes dark. Not cloudy, not sunset, not an eclipse. Just instant, absolute darkness. The sun, the massive nuclear engine that powers all life on Earth, simply switches off. No light, no warmth, no warning. It stays dark for 10 full seconds. Then it comes back as if nothing happened. The question is, what would those 10 seconds do to Earth and to us? Welcome to TechMind 999, where we explore the science behind impossible scenarios and uncover what could really happen. To understand the consequences, we must first understand what the sun truly is. The sun is not just a glowing sphere in the sky. It is a gigantic fusion reactor, converting hydrogen into helium every second and releasing unimaginable amounts of energy. That energy travels about 150 million kilometers across space to reach Earth in roughly 8 minutes and 20 seconds. Every sunrise you see is actually sunlight that left the sun more than 8 minutes earlier. That detail matters because if the sun suddenly went dark, we would not know immediately. Earth would continue receiving sunlight for 8 more minutes. Then, without warning, darkness would arrive. At the exact moment the last photon of sunlight reaches Earth, the planet would be plunged into darkness. Not gradual dimming, not twilight. Total night across the entire sunlit half of the planet. Cities in daytime would instantly look like midnight. Shadows would vanish. Solar panels would stop generating electricity. Outdoor events would freeze in confusion. For 10 seconds, Earth would resemble a rogue planet drifting silently through space. But would we freeze instantly? Surprisingly, no. Earth's atmosphere, land, and oceans store enormous amounts of heat. 10 seconds without sunlight would not cause dramatic temperature drops. The planet does not cool like switching off a lamp. Thermal inertia would protect us in the short term. Most people would experience confusion and panic rather than physical harm. The temperature change would be almost undetectable. The psychological impact, however, would be enormous. Imagine billions of people witnessing the sky go black at the same time. Social media would erupt instantly. Emergency lines would be flooded. Some would assume a massive eclipse, though eclipses never cover the entire Earth simultaneously. Others might fear war, cosmic disaster, or something supernatural. The uncertainty would be more terrifying than the darkness itself. Animals would react instinctively. Birds might attempt to roost. Nocturnal animals could briefly awaken. Insects guided by sunlight might shift behavior. Plants, however, would barely notice. Photosynthesis would pause, but 10 seconds is far too short to cause biological damage. Nature would pause, and then continue. Now consider something deeper: gravity. The sun's gravity holds Earth in orbit. If the sun went dark, what does that actually mean? If it simply stopped emitting light but retained its mass, Earth's orbit would remain unchanged. Darkness does not eliminate gravity. However, if the sun somehow vanished entirely, mass included, Earth would continue orbiting normally for 8 minutes before suddenly flying off in a straight line into space, no longer bound by solar gravity. But in our scenario, only the light stops. The mass remains. Earth stays in orbit. In space, the event would be surreal. Satellites relying on solar energy would switch to backup batteries. The International Space Station would enter unexpected darkness. Astronauts would witness the sun disappear, stars becoming visible even in what should be daytime orbit. For 10 seconds, near-Earth space would resemble deep interstellar night. On the ground, power grids might experience minor fluctuations. Solar farms contribute significant electricity in many regions. A sudden drop in solar input across half the planet could briefly strain energy systems. Modern grids have buffers and backup sources, but a synchronized global solar interruption would be unprecedented. Engineers would scramble to determine whether the cause was technical or cosmic. Yet the real fear would not be physical damage. It would be uncertainty. Humans depend on predictability. The sun has risen every day for billions of years. If it suddenly failed, even briefly, scientists would urgently seek answers. Was it an unknown stellar fluctuation? A cosmic obstruction? Some new astrophysical phenomenon? The sun is considered a stable main sequence star, not prone to sudden shutdowns. Such an event would challenge fundamental physics. Let's examine the science. The sun produces energy through nuclear fusion in its core. Immense pressure and temperature force hydrogen atoms to combine into helium, releasing energy. For fusion to stop instantly, core conditions would need to change drastically, something impossible under known physics. Even if fusion ceased, it would take thousands of years for changes in the core to affect the surface because energy moves outward slowly. A 10-second shutdown contradicts everything we know about stellar structure. That is what makes this scenario so fascinating. It forces us to imagine physics behaving differently. If the sun's light vanished while its internal structure remained stable, perhaps an unknown phenomenon blocked photons from escaping. During those 10 seconds, Earth would cool by only a tiny fraction of a degree. Oceans would not freeze. The atmosphere would remain stable. Life would continue. But psychologically, the event could shake civilization. Financial markets might halt trading instantly. Defense systems could enter alert mode. Conspiracy theories would spread within minutes. Religious interpretations might surge. The global reaction would reveal more about humanity than about astronomy. After 10 seconds, sunlight would return abruptly. Streetlights triggered by sensors might flick on and off. Birds mid-flight would adjust. Conversations everywhere would turn to the sky. Within hours, scientists would analyze satellite readings, solar observatory data, and neutrino detectors. Neutrinos, nearly massless particles produced in the sun's core, reach Earth almost instantly because they rarely interact with matter. If fusion had truly stopped, neutrino detectors would show changes even before the last sunlight arrived. Comparing neutrino data with light measurements would reveal whether the event originated in the sun or was caused by something external. Even 10 seconds of disruption would transform scientific priorities. Funding for solar observation would surge. Governments would invest heavily in stellar monitoring. Humanity would be forced to confront how dependent we are on a single star. Now push the scenario slightly further. What if the sun not only went dark visually but also stopped emitting heat for 10 seconds? Again, the immediate temperature change would be negligible. Earth's climate responds slowly. However, if such interruptions happened repeatedly, even briefly, atmospheric circulation could eventually be affected. Climate stability depends on consistent solar energy. Once is harmless. Frequent disruptions would be concerning. Precision instruments would certainly detect the event. Climate satellites measure solar irradiance continuously. A 10-second dip would become one of the most analyzed data anomalies in scientific history. Consider human biology. Our circadian rhythms depend on light exposure. A 10-second darkness would likely have minimal physiological impact, though extremely sensitive instruments might detect tiny hormonal fluctuations. It would not disrupt sleep cycles or metabolism. Transportation systems might experience brief confusion. Pilots rely on instruments, so flights would remain safe. Drivers, however, might panic if daylight vanished suddenly, potentially causing accidents. The danger would come from shock, not temperature. Space weather centers would initially suspect a solar anomaly. Solar flares increase brightness, not eliminate it. A complete absence of light would defy known patterns. The scientific community would be united in investigation. When sunlight returned, relief would sweep the planet, but so would anxiety. The realization that our star could fail, even briefly, would shift our sense of cosmic security. Humanity might feel vulnerable on a planetary scale for the first time. Philosophically, the event would be humbling. We often believe ourselves technologically powerful, yet every breath, every harvest, every ecosystem depends on steady solar energy. 10 seconds of silence from the sun would remind us of that dependence. Children would ask, could it happen again? Scientists would reassure the public that known physics does not allow such behavior. The sun cannot simply switch off for 10 seconds under current models. Stellar processes unfold over thousands to millions of years. The most realistic answer is that such an event is virtually impossible. Yet exploring impossible scenarios teaches us something valuable. It reveals the delicate balance sustaining life. Every second, the sun delivers roughly 173,000 terawatts of energy to Earth. Remove that energy long enough, and our world becomes an icy wasteland. 10 seconds is harmless. 10 weeks would begin catastrophic cooling. 10 months could freeze oceans. Time is the key factor. So what would truly happen if the sun went dark for 10 seconds? Physically, almost nothing. Psychologically, global shock. Scientifically, intense investigation. Philosophically, a powerful reminder of dependence. When the sun returned, sunlight would feel different, more precious. We rarely appreciate constants until they falter. The Sun has shone steadily for 4.6 billion years and will likely continue for another 5 billion. Human civilization exists during a remarkably stable cosmic era. 10 seconds of darkness would not destroy Earth, but it would change humanity's perspective forever. If you enjoyed this exploration of cosmic possibilities, subscribe to TechMind 999, where science meets imagination, and where we question the universe one impossible idea at a time.